Okay, to do this part here, I'm not going to do the whole thing. I mean, I'm just going to show you guys a few things on how to answer this lab. When you start here, there's a chart that shows you how to name compounds. So far, I'm still working on the PowerPoint, so I'm about halfway down. I've done the ionic part, and it shows you essentially how to name the compounds by following the chart. I have yet to do the molecular or covalent part that covers the acid and the regular molecular compounds. I will get into that. But I would say, and oh, by the way, before you get to the lab, there's a list of common polyatomic ions. You want to have this list close to you because this will help you whenever you're working on the lab. Okay. So for this one here, to answer this, notice that the anion comes before the cation, the negative charge comes before the positive charge. So please do the reverse crisscross. Don't just eyeball to get the charges of the cation. So for the most part, let me do the first one for you guys. This first one here is copper and then phosphorus like that. So when you reverse crisscross, you end up with the 2 being in front of the copper, or I guess superscript to the copper, right? And then the 3 being superscript to the phosphorus. So 3 minus. So essentially you end up with copper 2 plus and phosphorus 3 minus. Remember, you put the plus 2 here, and then you put the minus 3 here for the anion. This represents the phosphorus, this is the copper. And you essentially go through and complete the table. This part I think is very easy to finish because you're writing the charge based on the group number. And these are all group A elements, so they'll have a particular charge, a fixed charge all the time. Okay, when it comes to naming the compounds, I'm only going to do this part for you, this first part. I want you guys to, oh yeah, all the way to 20. I want you guys to, you know what, I'll be generous. I'll go all the way to 20 in labeling the compounds. But for this part here, I want you guys to actually go through and label like I'm going to show you guys this part here. So no, I am not naming these compounds for you guys. What I'm doing is showing you the type of compound based on what we're going to be covering. So once we cover the whole of chapter 6, please notice you are judging the compound and labeling the compound based on the identity of the first element, okay? So let me scoot this to the side a little bit so we can see. So on our left here, we know that we have the zigzag goes, let's see, it goes through here like that, right? Yeah, through here like this. And the zigzag separates the non-metals from the metals. So we have potassium here as a first element. We know potassium is a metal because it is to the left of the zigzag. So potassium is a metal. Being that is a metal and it's in 1A, potassium will be a ionic A complex. I'm going to write here ionic A. If it's a metal, the compound is going to be ionic. If it's a metal, as in group A metal, whether 1A, 2A, or 3A, the compound will be named in ionic A format. And then let's see. Let me go identify all the ionic A's. Copper. Let me close this because I don't need this one. I'm going to just easily drag this. Okay. Copper. Since this, I'm not naming this, I can zoom out and make it easy for me to scroll back and forth. Okay, copper is right here. Copper is ionic B. See how it's B? Okay, so copper will be ionic B. Okay, I mentioned this earlier. In the ionic B, zinc and silver are the exception. In the ionic A, this group right here, this group of 4. Indium, tin, thallium, lead. Actually, that includes antimony and bismuth. So these 6 right here are going to be those exceptions that do have multiple charges, okay? The more common ones we see are the 4. We rarely ever do much with indium and thallium, but mostly these 4, okay? So I usually focus on the 4 that we look at, these 4 here. Okay, where was I? Aluminum. Aluminum is part of that A metal that has a fixed charge. So you will name it as ionic A, okay? Magnesium, also a metal. Remember the zigzag is around this, right? Around underneath boron, silicon, and stuff. Magnesium is to the left of that, so it's going to be a metal. It's 2A, so it's going to be also ionic A. They have to have the same format. Manganese is a B metal. It's not the exception, right? It's a regular B, so you're going to have a ionic B. You see how I'm going through this and labeling it based on the type? When you're actually providing the name of the compound, those that are ionic B have to have the same format, right? Remember ionic A, let me go back and erase this. I just meant to erase, that's all. I think I scrolled back. Those that have ionic A format will have the element name. This is ionic A format. And then the anion. I'm writing with my mouse, excuse my handwriting. This is ionic A format. Ionic B format has 3 components. It has the element, it has the charge, and then it has the anion. I'm writing with my mouse once again. Excuse the horrible handwriting. Okay, so the, ooh, can I go back? Oh, there. Okay. I'm like, I need a do-over. Okay, there. The charge is in parentheses. So the charge in parentheses is what distinguishes ionic B from ionic A. Okay, so moving down here, once again, decide based on the identity of the first metal. Sodium is ionic A. Ionic A. Potassium, also ionic A. Chromium, the B, ionic B. Zinc, it's a B, but that's one of the exceptions. So I write here ionic B with the star to remind myself, yeah, it is ionic B, but you will name it as though it's ionic A. So it will only have 2 names, no charge, okay? What about tin? Tin, see, that's one of the 4, right? The common 4 that we see from here. Tin is ionic A, but it has multiple charges. So you're gonna put a star here. So even though it's ionic A, you will name it like it's ionic B, okay? And then let's see, sulfur. Sulfur is to the right of the periodic table. So even though I haven't covered this in the lecture part yet, I'm gonna cover it in the lab. Sulfur is to the right of the zigzags. The zigzag goes down here. I can't draw on this. To the right is a nonmetal. So the nonmetal, we'll name it as molecular compound, okay? Phosphorus, also to the right of the zigzag, molecular compound. Chlorine, to the right of the zigzag, molecular compound. Sulfur again, molecular compound. Phosphorus again, molecular compound. You see? And in the molecular compound, remember, molecular compounds, their names have got 4 components. You have the prefix. The prefix represents the number of the first element. Then you have the element name. And that's going to be this first element here. And then you have the prefix, where the prefix tells you the number of the second element. And then you have the anion name. Okay. Then down here, once again, I'm just focusing on the type. Now I'll do one example of each category. Then that will be it. I'll let you guys do the second part here. But right now, I'm focusing on the type and you recognizing the type of formula. These all start with hydrogen. So because they all start with hydrogen and they're not water, there's no H2O here. These are all acids, right? And as I'll cover in the lecture, the acids tend to be of 2 main types. You have the binary acid and the binary acid, you just have an acid and another nonmetal, right? So H and N, acid and another nonmetal. And then you have the oxy acid. The oxy acid, if I can write this down, I'm making it. There's a hydrogen, there's an oxygen, and then another nonmetal. So you essentially have 3. Remember, binary means 2, right? So for the most part, in the binary acid, you have hydrogen and another element. Oxy acid, you have hydrogen, another element, a nonmetal, and the oxygen. So keyword here, oxygen. Let's look at all the acids that have oxygen in them. Oh, I'll use the letters Ba for binary acid, OA for oxy acid. Okay, so this one here is going to be oxy acid, oxy acid, oxy acid. Okay, and then the one that has no oxygen is going to be binary acid and binary acid. So remember, in the name, the names will follow the format of nomenclature. Okay, so after I've written all this, remember binary acid, as we've done in lecture, binary acid follows the nomenclature, which is, this is all just a review. Okay, so you don't want to do the lab before you do lecture. The goal is not to give you an out for lecture. You want to do lecture, then you do lab. Okay, so here we're going to have hydro. I'm going to do number 18. All binary acids follow this format of nomenclature. They start with hydro. So hydro, and then you're going to have the stem part, right? The stem word of the nonmetal. So the nonmetal here is iodine. So remember, iod is the stem word. So hydro. Oh, sorry, I'm writing the template. I almost forgot. Sorry. I'm writing the template and I'll give the answer right there. Hydro, stem, ic, acid. Oops, forgot how to spell. Acid. It's a little hard to write with the mouse. This is the format that binary acids have to follow. So following that format, this is going to be hydro, iodic acid. Okay. And then for the oxy acid, let me pick one. I'll name the number 17. For the oxy acid, you're either going to have stemic acid. There are two choices to pick from, or stem-us acid. Stem O-U-S acid. Remember, the stemic acid comes from polyatomic ions, right? That end with 8. So essentially the ones that ended up with 8, because they had a lot of oxygen, became stemic acid. And then the anions, polyatomic anions that end up with ite, became stemous acid. So ite becomes stemous acid. Okay, so to name, so in my case here, let's see, my anion is called nitrate. That's the name of this anion, right? So to make an acid out of that, you add the hydrogen ion. Once again, I'm not teaching this for the first, this is a review from lecture. And then the acid, which is just this compound here, is named, replace the 8 with ic acid. Nitric acid. Nitric acid. Okay, excuse the bad handwriting. But anyway, okay, so now that we've done this, let me go ahead and I'll go through here with the first one. Let me give an example of this. So the element anion for the ionic A compound, name potassium as the element. So go back here, remember potassium. I'm not going to scroll all the way out because I'm trying to get this done. Potassium. Use the periodic table. Make sure you have one next to you. Potassium for the metal. For the sulfur, let's see, for S is to the right over here. Don't write not potassium, sulfur, but you want to say sulfide. So you want to go to that table in the PowerPoint where I showed you guys the stem words and use that. Potassium sulfide. Oh. Okay, potassium sulfide. And this next one here is 1B. 1B with this one here, okay. Let me actually show you how to do that. We want to get the charge on the first element, which is the metal here. So we have to reverse, right? There is nothing here, so the 1 is implied. Reverse here. Bring this back up here. This is going to be Cu plus 1, right? O minus 2. This is, it's an ionic B. You have to include the charge, right? The element named the charge. The element Cu is copper. The charge is going to be 1. And then this is over here. It's called oxide. So copper 1 oxide. Okay. So I'm done with the example of 1A. I'm done with the example of 1B. I'm done. Oh, I didn't do this part here. Prefix, element, prefix, anion. For the molecular compound, remember, in this compound here, we only have the prefix. We only have 1. Remember the nomenclature, we don't include mono in the prefix. So don't include that. Skip the mono. And then go straight to naming the element. The element is S, so that's going to be sulfur. I'm done with that part. Then the prefix to the second one tells me how many atoms the second one I have. I have 4. That's going to be tetra for 4. That's the prefix we use for 4. Tetra. And then the anion name, F, is called fluoride. Fluoride. So instead of saying mono, sulfur, mono means 1. We don't include mono. So sulfur tetrafluoride for this. So I gave you guys an example of that. Once again, don't skip the lecture part to go straight to the lab because now it will be confusing. Okay, so what I'm going to do here is go through and try to pick out compounds that have the ionic A format. I'm looking for 2 names. First one being a metal, second one non-metal, right? So we're going to pick a couple here, the names. Here, ionic A. 2 names. First one metal, second one non-metal. Another one, ionic A. I'm going to stop here. You will continue and you're going to label all of these, right? According to the template in the format we just covered. The next one, I want to pick a couple of ionic B. For ionic B, I'm looking for the easiest way to identify ionic B. Ionic B, I'm looking for the charge. Once I find the charge, I'm looking at ionic B compound, right? All I need is the charge. So I'm going to scroll down here, right there, ionic B. So easy to find this. There, ionic B. Okay, I'm going to stop here. I won't go any further. Next one, molecular compound. What makes molecular compound nomenclature unique? They're the only ones that have the prefix. They have a prefix. I should say they're the only ones. They are the ones that use the prefix mono, di, tri. So, you're looking for prefixes like mono, di, tri, tetra, the 1, 2, 3. That's what you're looking for. Once you find the prefix, you found your molecular compound, right? So we're going to look for molecular compound by looking for prefixes. Okay, there's no prefix here. There's no prefix here. I would say the easiest way is to look for the prefix in the second name because remember the first one can be skipped. This is a prefix, but this prefix just means many. It's not describing an actual number. So this is not what I'm looking for. I'm looking for a prefix like mono, di, tri. I don't see any here. No monodite. Ooh, penta. Penta means 5. Sorry, 5, right? So this is a molecular compound. Penta means 5. This is a molecular compound. Another prefix here. Yeah, mono means 1 molecular compound. You see how I did? Yeah. Okay. Then for my acids, it will be easy if they have acids. They usually have this sign aqueous to indicate acids, right? But with the acid, you're looking for this format. Stem-ic acid, stem-us acid. Let's see if they have the word acid here. Look at that. Acid, 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 acid. Okay? So stem-ic acid, stem-us acid, these are the oxyacids. Then the ones that start with the word hydro, it has to start with the word hydro. That will be the binary acid. So I'm looking for the first prefix being hydro, okay? This first. So now label that Ba. So we see where it has acid, acid, acid. These ones are all acid, hydro. Oh, there. Ba, binary acid. Do I have another hydro? This doesn't count. This is hypo. I need hydro, okay? Hydro, another Ba, you see? Okay. Now, I took care of all the Bas. Now I'm going to try to find the oxy acid. With the oxy acid, remember the two types, two naming formats? You have the stem ic, the one that ends with the ic, and the one that ends with the OUS. So it's a not really ends, but it's a suffix, right? Before the word acid, we have stem ic acid, stem us acid. The us came from the I. So let me see if I can identify that. Oh, look, us acid. This is going to be an oxy acid, okay? Ic acid, also oxy acid. You see the ic acid, us acid, oxy acid, oxy acid. So essentially, these are all oxy acids. And remember, to get to the us acid, you came from the ite. To get to the ic acid, you came from the eighth, right? The A and iron, the ite and iron, the ate and iron, the ite and iron. This is it, y'all. I'm going to let you guys figure out the rest of it, do the lab by yourself, but I feel like I've given you guys enough information to complete this lab and turn it in. Okay. If you still have questions, please email me. Let me know.